Hello and welcome to section 3.5, which is on parallel lines and triangles. Postulate 3.2, parallel postulate. Through a point not on a line, there is one and only one line parallel to the given line. So if there's a point outside of the line, there could only be one line parallel. And I'll draw you a little example. So if I have a line here, and then I just have a point somewhere that's not on that line, what they're saying is I could only draw one line through here that would make it parallel to this one. That's what that postulate is saying. Theorem 3.11 is one that we learned in 7th and 8th grade. Triangle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. We should all know that. Any triangle has 180 degrees in it. Auxiliary line, a line that you add to a diagram to help explain relationships and proofs. So it's one that's not really in the picture, but you add it, like this one right here. I added this on to explain this exterior angle of a polygon, which is an angle formed by a side and an extension of an adjacent side. So just like right here, you could extend this side, you could extend this side, this side. Okay, those are exterior angles, and there's things that we know about exterior angles that we'll go through. It makes a straight line, right? So this one and this one added together would be 180. There's things that we can do with that. Remote interior angles. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. So then I wrote in parentheses here, angles 2 and 3 from this drawing are the remote interior angles. They're the two that are not connected to the exterior angle. So these two right here. Theorem 3.12, triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. So what they're saying is angle 1 would be congruent to angle 2 and 3 added up. And that would make sense if you think about it, because angle 1 and this angle that it's not marked would add up to 180, right? And so then if you subtract this one from 180, what's left is 2 and 3. The same thing here. If I have 180 and I subtract this one, what's left is angle 1. So angles 2 and 3 would equal angle 1. So then for my example here, I have written 70, I have a picture to go with it. 70 plus 30 plus x would equal 180 degrees, and that would make sense, right? So I need to find x and y from this little example right here. So the three inside angles have to add up to 180. So 70 plus 30 is 100, so I just combined it. Then I'm going to subtract 100 from both sides, leaving me with x equals 80 degrees. Okay, that's a fairly simplified problem. And then actually, if you just think about it, x and y share two lines right here. So they would be vertical, so then it would be 80 degrees for y. Or you could actually go through and figure out, right, the answer also. Knowing that this one is 80, you'd know that this one right here is 100, and these two together make a straight line, which would be 180, so this one has to be 80, just the way it is. These two would both be 100. How do you know that? Because the remote interiors add up to 100. And one more example. So we're going to do another proof here. We're going to prove the triangle exterior angle theorem, which is theorem 3.12. It just says that the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So we're going to prove it. So given the information they give you is that angle 1 is an exterior angle, and then they want you to prove that the measure of angle 1 equals the measure of angle 2 and measure of angle 3, going through a series of logical steps. And I'm going to do the two-column proof. That's my favorite proof to do. It's just the most organized to me, and it makes the most sense. So I have my statements on the left and the reasons on the right. I have angle 1 is exterior, and that's given. Okay. So from there, what's the next thing that I do know? I know that angles 1 and 4 would be supplementary. Okay, I can't use 2 and 3 yet because I haven't proven anything about them yet. So, but I do know that 1 and 4 together add up to 180 degrees. How do I know that? Because it makes a straight angle, and those are supplementary. or excuse me, I know they're supplementary, which also means that for the next step, I know they equal 180 because that's supplementary angles, definition of supplementary angles. That's how many degrees are in those. Next step is saying that measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. So all of these on the inside equals 180. How do I know that? Triangle sum theorem. The measure of angle 1 and angle 4, these two, have to equal the 3 on the inside, because these two equal 180 and these 3 together equal 180. What did I do there? I just substituted in. Substitution property. So then I know that the measure of angle 1 plus the measure of angle 4, equals the measure of angle 2 and the measure of angle 3 together. How do I know that? Subtraction property of equality. What did I do? I subtracted 4 from here, the measure of angle 4, and I subtracted the measure of angle 4 from here, which left me with this piece right here and the measure of angle 1. And so therefore, there's my series of steps that prove that theorem. So bring that information with you, and we will talk about it more the next time I see you. Have a good night.